Alright, what's up guys? In this video we're going to pick up some multivariable calculus, and we're going to be talking about arc length and applying that to finding the arc length of vector functions. So we're asked to find the length of the space curve with the given vector equation here. R of t is equal to 4t, comma 3 cosine t, comma 3 sine t over 0, comma 2 pi. So I apologize for the noise in the background. I have two nephews, a 3-year-old and a 4-year-old, and they're playing with toys. So as you can hear, they're having a good time. So bear with me on that on video. So I apologize about the noise. I'll try to speak loud so you don't hear it too much. Okay, so to find the arc length vector function is pretty straightforward. Let me just remind you that to do our arc length, remember that's just L is equal to the integral from A to B, and it's going to be the magnitude of R prime of t, or the norm, and then you'll integrate that with respect to t. If you're given some vector function, R of t is equal to f of t, g of t, and h of t. Okay, so I mean, again, all we really need to do to start this is begin by finding the first derivative of R of t, and we just take the derivative of each component of that vector function, and we'll take it from there. So we'll get 4, we'll get minus 3 sine t, or sine of t rather, and then we'll get 3 cosine of t, and that will be our first derivative. Now we need the magnitude, or the norm, which is the square root of the sum of the components squared. So we're going to have the square root, and it looks like we'll have 4 squared plus negative 3 sine of t squared plus 3 cosine of t squared. And so if I take the square root and we simplify, that's a terrible square root, by the way, sorry. Okay, so we know we're going to get 16 plus 9 sine squared of t plus 9 cosine squared of t. Now remember that sine squared of t plus cosine squared of t is equal to 1, and so I guess to kind of demonstrate that, let's demonstrate it. So we would just have 16 plus 9, and then again sine squared of t plus cosine squared of t is equal to is going to be equal to 1. So really what we're looking at is the square root of 16 plus 9. 16 plus 9 is 25. So really what we're looking at is the square root of 25, which is obviously 5. So we know that the norm, or the magnitude of R prime of t, is going to be 5. Now we need to take the integral of that with respect to t, and I'll just put it under here, and we'll get another sheet. So let me get another sheet here. Actually, no, I'm gonna need it, so I'm gonna I'll put it right there. Okay, so now we need to take the integral of all of that from 0 to pi over 2. So L is equal to the integral from A to B. It's going to be the norm, or the magnitude of R prime of t with respect to t. So what this is going to be is the integral from 0 to 2 pi. If I said pi over 2, I meant to say 2 pi. If I said pi over 2, I apologize. From 0 to 2 pi. And we're integrating this constant here with respect to t. And obviously that's just 5t from 0 to 2 pi. So we obviously get 10 pi minus 0, which is just 10 pi. And that's your arc length, 10 pi. So for our final answer for this, our arc length is simply going to be 10 pi. And that's pretty much your answer. So, pretty straightforward, right? Hopefully so. So let me know if you got any questions about it. I love answering questions about this type of stuff. There's no such thing as a dumb math question. So don't be afraid to ask, because I guarantee you the question that you have is probably the question that a lot of people have, and you're probably not the only one that has a question about it. So that's your answer. Alright. Y'all take care, guys. I'll see y'all next time.